Okay. Hello, everyone. Today is December 8th, 2022. Welcome to today's edition of Kubernetes Batch Working Group. I'm going to be moderating your meeting today. I'm Swati Sehgal. I work for Red Hat. And I would like to let everyone know that this meeting is being recorded. And please keep in mind CNCF Code of Conduct when you engage in this meeting. We have two items today. The first one is from Wilfred about Unicorn Scheduler. Wilfred, feel free to start off.
Okay, good morning. I'm Wilfred. I work for Cloudera, and I'm the tech lead on the Apache Unicorn project. And I was asked by some of the work group people to present on what we do around our gang scheduling, the all or nothing stuff that we have set up. So I've created a short presentation, so if I'm allowed to share my screen, and
yeah, you should have host access now.
Okay, thank you. I've prepared a short presentation around what we do and how we've implemented gang scheduling. And some of the reasons behind what we did, or I'll talk about, and compare that in a number of ways to what's available currently Kubernetes. So, the gang scheduling. So, if we look at what gang scheduling does, I've spoken to this before in May at Kubernetes, the KubeCon in Europe. We looked at gang scheduling, and what we did is we said we need something or some way that we can tell or can schedule an application based on a larger request than one pod or a multi-pod request. So what we do, and we looked at it specifically from a Unicorn perspective, we said we want to introduce that kind of scheduling based on an application object or an application aware kind of a scheduling. So an application within Unicorn is a loose definition of a set of pods. And that is purely based on the fact that there is an annotation on the pod that is an application ID. So it doesn't have to be a set of 5 of the same pods, or it doesn't even have to be pods that get submitted all together. It could be one pod of one type and 10 pods of another, but it could be 10 different types of pods also. So that's the basis of what we did. The other thing that we wanted to do is we wanted to be quota aware. So within Unicorn, we don't use the Kubernetes namespace quotas. We have got quotas set up in a queue system, and that is purely hierarchical. So we've got multiple queues within the Unicorn scheduler. And within that hierarchy, we set up a quota, and that quota runs for that specific queue at the root, and then we can have children of that root and children of the children, etc., etc. So that gang scheduling that we would set up had to fit in with that quota system that we do. It means that we do not enforce quotas when you submit an application or a pod, and we only admit and we only enforce that, and we use the quota when things start running. So that's the 2 points where we said, okay, that needs to fit in with our gang scheduling. Other goals that we said we needs to be usable with all kinds of workloads. We schedule a lot of Spark workloads as batch workloads, but we've also got workloads for services that we want to schedule, or there's people that start up Python jobs, and it needs to fit in with all these kinds of different workloads. So we don't want to prescribe and say you need to do a job, or it needs to be a daemon set or whatever. No, any type of workload what people could create needs to be supported. We also had a view of we want to have a minimal impact on the submission. So that means whatever we need to do, it needs to fit in with existing applications like Spark and other objects and other ways of submitting things. So the third point was cluster autoscaler. Whatever we do, it has to fit in with the cluster autoscaler without making any changes to the cluster autoscaler itself. The fourth point that we said, okay, we want to be flexible. We want to be flexible in the way that we define what a gang is, but we also want to be flexible in the way that the parts or the bits of the gang are used. And that means that we want to be able to say, if somebody wants to define gangs on an application, or one gang for an application, or 10 gangs on that same application, we need to be able to do that. So we have to be able to be flexible, define that, and work with that. And because we want to support multiple Kubernetes versions, Unicorn runs as a scheduler against a widespread of Kubernetes versions. We said we don't want to introduce new Kubernetes objects or an API, because that limits us for when we can start using it and which versions the end users can run as a Kubernetes release. So based on all of that, we started working on our gang setup, and we wrote a design doc. It's available on the Unicorn website. And we have been running with this gang design for, I think, about a year and a half now. And we're running it within production, and it's being used by a number of larger Spark users in production. It's mainly Spark users that are using this. So let's first take a step back, and then we'll take Spark as an example. So what happens when we start scheduling a Spark application, and how does that work with either Unicorn or with the default scheduler? From a Spark application point of view, when we submit the Spark application, we create the driver pod. The driver pod gets scheduled, and after the driver pod gets scheduled, the driver pod itself will create a number of executors. So when we submit the Spark application, we don't know exactly what the whole demand will look like. We don't know beforehand if that submission will create 1, 2, 3, or maybe even a couple of thousand executors. So that's the start that we've got. A bit difficult. So it also means that the driver does not define at that point in time how many executors it will use over the lifetime of the Spark applications run. Now, every driver that creates a number of executors, and every executor is a pod, and it will just get scheduled one by one up until it's needed, and when it finishes, that's the end of the Spark application. The number of executors and the configuration of the executors is included within the driver. So that's the part, that's the area that we know how much we do and what we've got. But it's not known at a Kubernetes level up until the driver gets started and then the pods get created, what the executor pods look like. That's a problem with predefining. If we need to predefine things that we run with the gangs also. So what have we done? Let's first have a look at the gang specification. So using gangs and the whole gang scheduling, what we've said is when we use gang scheduling, we specify the gang, the all or nothing setup on the first pod that gets submitted. So in the Spark case, that could be the driver, or if you use anything else, we've done this with just Kubernetes jobs. You specify the gang information on the first pod that gets submitted. And that's where we read it from. It's purely a simple annotation under the Unicorn namespace. And the annotation consists of a number of elements that we use. So, like I said before, we can define multiple sets of pods, and that could be just one type for everything that runs within that application, but we can also have 4, 5, or 6 different groups in there. So distinguishing them by name, we set up a number of members that we want to create or that we're expecting to be used. A little bit more about that in a second. And we specified the amount of resources, and we also allow you to specify a set of node selectors, tolerations, and affinities for that specific group. So in the first design and the first setup that we had, we did not have the node selectors, tolerations, and affinities included in it. Later on, when we started looking at the more advanced use cases, we understood that we had to get that in there to allow proper placement to just work also. Based on the number of members that we require and the number of groups that we've got, we create placeholders on Kubernetes. So as soon as we start scheduling this application, we say we want to create enough placeholders on the system to take up all the quota and make sure that it fits within the running system before the real pods appear. So if we go back to the Spark kind of a setup, the only thing that gets submitted is the driver. So we don't know the number of executors or what will be requested. So if we don't know that, we can't reserve the space, so we can't schedule it as a gang. But what we do know is if this annotation is there and we've got the gang definition, we can create whatever we want based on these gang definitions. So what we do is we create placeholders, just simple pause pods, and the pods that get created use this as a pod spec. So we know now that for this task group, we use 100 milli CPUs, 50 meg of memory with all the node selectors and everything like that. All these placeholder pods will get scheduled, and we put all these place pods on the system, and we now say we start scheduling those pods. We hold back the other pods. We'll dive into that in a little bit. So beside the pod specifications for the placeholders, we also have got a policy specification. Again, on the first application pod, we have not just these task groups that we specify, but we also have a policy that we allow you to specify. Because what we want to do is we want to be able to say, do not reserve these placeholder pods that we've got forever. Time them out, because if we haven't used them or there's something else going on, we don't want them to sit there forever, and we just want to make sure that we can time them out. And that's something that the customer knows. They know the behavior of the application. So we allow you to set a timeout. The timeout is the number of seconds that those placeholder pods that we create based on these pod specs can exist on the system after being scheduled. We also have a gang scheduling style, because what we ran into was customers asking us, saying, okay, we want to be able to, if you can't give me all the placeholder pods and it doesn't fit within the system, then I'm happy for the application and for the thing to still run, but just as a normal scheduling cycle. So no placeholders. We just want to do then pod by pod, and we'll see what we can do. So we've got two mechanisms, a hard and a soft one. The hard one was like, if I can't get all the pods defined in my gang, I fail the application. Go on. That's the basis that we started with, and say, give me 10 pods of this size and then 5 pods of the other size. If I don't get all these 15 pods within a certain time, I failed the application, and that was the startup for what we did. But people then said, "Oh no! If we only get some of these pods, I still want to have the application run, but without any of the gang style involved." So we do a soft system. We try to get all the placeholders, but then if that placeholder timeout expires and we haven't got all the placeholders by that end of time, we don't fail the application, but we say, let's just continue and try to schedule without doing any of the gang scheduling stuff. Yeah. Then the second part is using that gang specification. So we've set it up, we've got it on the first pod, we've defined all our task groups, but now we need to be able to say, use these placeholders that we've got, that we've created, and then use them during the scheduling cycle. And since we don't have the official pods at startup yet, we don't have to have them. We might have them, we might not. We need to be able to define that a pod that is part of the application also uses one of those placeholder pods and is member of that task group.
Sorry,
So
Wilfred. Sorry. Just a quick time check. We are 22 minutes in and we have another agenda item as well. Do you need long
correct.
for?
I've got about 3 to 4 minutes left.
Okay,
I'm as good as done here.
perfect.
So
Thank you.
the next step, the next step is we want to use this gang specification. So on every single pod that we have, we create or we put another annotation on, which defines for us which member we use, and we use the placeholders. So we've got some checks and balances on that. We've got an opt-in kind of scheduling setup. So if you don't use all the placeholders, we clean up. If you use more, we treat them as normal pods and we go through. What we also saw is that people sometimes have got different requests in the setup than that they have on the real pods. So all that the difference is being accounted for during the scheduling cycle. Now, the scheduling cycle looks a bit like we hold the pod, we create placeholders, we replace the placeholders, or you release them in the end if it's not done. A real quick overview of what that looks like in the gang for the Spark setup. We've got a driver. We specify the gang as one driver, 3 executors. That means that we create these 4 placeholder pods on the system. These 4 placeholder pods get scheduled by the scheduler, and at that point we release the original driver pod that was created, and that original driver pod will start creating the executors that are now created. So we've replaced the driver placeholder, and we schedule the executors that now come into play one by one, and we replace the placeholders that are there. And in the end, we've got the whole application up and running. So from the moment that we create the placeholders, we are using the quotas in the queue and in the system. And if that would not completely fit, so if you ask for, let's say, one driver and 3 executors, but it's more than your quota that's available, then we reject the application already for you. So again, we've got some checks and balances around all of this, but this is a flexible way that we use to build and schedule gangs around Spark or any other application that you want to do. That's a quick overview. There's multiple examples, multiple ways of doing things, and all the documentation and everything, like I said in the first slide, is on the Unicorn website. Things.
Thank you. Thank you very much for the presentation. I would really appreciate if you could add a link to the agenda with your presentation. It would be great for people to reference it later. There's a question from Abhishek. There's a question from Abdullah as well, but I'll start from a question from Abhishek, who's asking, do we lose the guarantees of running the app when quota is evaluated later? And is there a scenario for a partial job or a pod start?
Yes, so we do have, so there's 2 things. If the whole gang doesn't fit within the quota, we reject the request and we say, sorry, you can't do this. This is out of quota or too large for the quota that you've got. If the request fits within your quota, but at the point that you want to run it, there's not enough quota available, then depending on the hard or the soft setup that we've got, if it's a hard setup for the gang, we fail the application. If it's soft, then we try to schedule within the quota that's available. So yes, we've got those 2 different kind of ways of scheduling things. And especially that last bit, if there's not enough quota available and we still go on and schedule, that came from requests of the users that we had around this option. So they really said, I do not want to fail the application. I just want to try to schedule within what is available at that point in time.
Perfect. Thank you. Abdullah, feel free to ask your question.
Yeah, sorry. Can you please go back to the gang definition on the first pod? So this works well like for Spark, where you have the driver first created, and so you can put that on the driver. But like for a V1 job, like you have to put it in all pods, right, of that job, because
Yes.
you don't know which one you're gonna see first.
Correct. Yes. Yep. In that case, when we do create jobs, we just put it on every single pod that is there, and depending on which pod we see first, because you can't even rely on the fact that when you create a job spec, things flow through the job controller, and we even see that with when we create placeholders based on what we do here. We create pods in a certain order, but going through all the event processing and everything that happens in the background, we get them back in a completely different order. So yeah, we can't rely on some kind of ordering anywhere in that system. So yes, if you do a job, you specify this on every single pod, because we don't know which one we're going to see first.
Right. And the placeholder pods are actual, like you create them after you check the quota for the gang, or before?
Yes. No, after.
Okay, and then after you create them, they are actual pods, like they're not like pods that create in memory in your scheduler.
No.
They're created on the API server. Okay.
Yes. Yep.
And then like you create them, you create them, and then they go through the normal scheduling process, and then the actual pods that need to schedule in their place, you somehow match them using, I guess, the second slide.
Correct. Yes. So we've got the names, and based on that name and the match that we've got in that annotation of the rest of the pods, we match that to a group again, because we could have 5 or 6 different kinds of task groups within that gang. So even if you submit an application and you later on submit a pod under that application, it could be part of the example group, but it could also be part of, and with Spark, we do that often with drivers and executors. It could be part of the driver group or part of the executor group. Or you could even, if you want to, say, oh no, this is something that I want to run outside of this guarantee, and you create a pod without any annotation, and then it just gets scheduled as one outside of that guarantee that you've created with the gang.
Right. I see 2 limitations here. So with this approach, so the first one is that like with Spark, you always have to have that task group name, so you don't know like, and so basically you are predefining what is the maximum that they can create, right? So it's not
so we allow you to go over the, so we've got in the spec here, we say we've got a minimum member, and that we treat it as a minimum member. So if you create pods that are that give the name example group as the as the pod that, but I've already scheduled 2 and there's no placeholder left, then I just treat that as a normal pod. So we're flexible. You can go over that. It's a minimum member. It's not a maximum member. So we are flexible because we need to be able to do that. If you look at dynamic executors in Spark, you give it a minimum number of executors in Spark, and that doesn't mean that it uses that number. It could use more but it could also use less. So we allow you to do both. So that's that checks and balances with that opt-in. If you use less pods that specify that specific task group, we have got placeholders left over. We clean them up after the timeout. If you use more of them, so if you submit another pod that has got a task group name, but there's no placeholder left, then we just treat it as a normal pod and schedule it as a normal pod, and we don't do any of the replacement stuff.
Right. The problem, one problem, because this is something similar to what we've been discussing with like general idea of reservations. So one thing that is going to be complicated is like basically you're trying to repeat the pod spec in the annotation, and I mean like you already have this problem where you had to add node affinity and then you had to add taints and tolerations, so and then validation, etc. So I would caution that this. I don't know how this will like evolve in the future in your case, but you can't always scale with like running away with keep pushing things into annotations. Annotations are not really an API. But the bigger problem I see is that you have cases where, for example, dynamic resources being allocated like PVCs on the fly using stateful sets, right? The stateful set controller creates the PVC on the fly when they create the pod. That you wouldn't know when you create the placeholder pods. So you wouldn't create a PVC for that pod. So you wouldn't be able to schedule them at all. So you wouldn't be able to provision storage for the future pods that will of the application.
Correct.
And
correct. So we we'll leave that up to the real pod that gets created.
But
so,
but if you already had that placeholder pod scheduled on a specific place, you don't have a guarantee that the PVC will actually schedule because it has sometimes some node affinity.
Correct.
It needs to be placed on a different node, and so that's
correct. We handle that. That we do that. We handle that with our scheduling internally. So if it turns out that that doesn't fit, then we use a different node and we move on for that. So yes, we do that. We already do that in our current set, because we've already noticed that sometimes when people specify all of this information in the task group, they don't set up any node selectors or tolerations or affinities, and then later when the real pod comes in, they do have that. So we already see that it's not just for PVCs, it already happens, and we handle that during our scheduling cycle. So that is done. So the placeholder might run on one node, and then the real pod gets scheduled on a different node later on. So we do that. That's handled. We saw that happen before. So yes, and that is not just for PVCs, but it's with everything. People are not always consistent. They say, oh, I just want to do the minimum. I want to make sure that it runs within the queue. So I only specify min member and min resources, do not specify any of the other things. And then later on, that gets done. We even saw people that said, oh, my placeholders are 1 CPU and 1 gig of memory. And then when the real pod comes along, they ask for 1 CPU, but for 1.5 gig of memory. And in certain circumstances, that doesn't fit on the node at that point in time. So again, you need to have fallback mechanisms during the scheduling, and that is all built into the scheduler. It handles all these edge cases with differences between the real pod and the placeholder that has been created. All that stuff, that's all handled.
Okay, I'll read up on that. Like, how do you handle the fallback, and probably in your design document. I don't want to take the whole time.
Perfect. Thank you, Abdullah. Thanks, Wilfred. The presentation was really interesting, and the slides as well. I would really like you to continue talking on this, but we have another agenda item, so I'd like to move to that. Thanks again. So we have Kevin here, and he wants to discuss about pending pods. Kevin, over to you.
Yeah, thank you. I'll go ahead and, oh, can I get permission to share?
Yeah, you should have
Okay.
co-host now.
Thank you. So this kind of came from a discussion I had on Slack about, I was looking at the retriable job idea for, I was trying to use that in Armada, and I realized that a lot of the cases we found in the Armada project were actually around handling pending pod issues, like invalid image names, a secret that is mounting a secret to a volume, a lot of other ones. And so I wanted to try and see if there was a way to kind of have that retriable job idea for pending pods, to try to say, like, my end goal would ideally be the job API can, or a batch job can predict whether or not if the job is stuck in pending due to configuration error, can it transition to failed, so that, like, a main use case for this is that for if people are scheduling large amount of jobs, and batch users are usually not Kubernetes experts, so they might have configurations like image pull secrets that are invalid, and a lot of the controllers do handle like this, like they might retry a job. And Armada, we actually have we have a controller that reads the container status or the container reason, and also we also read the events to know whether or not jobs or pods are failing. So I have kind of a potential idea that I want to run by this group. I'll skip to the bottom. I kind of went through the common examples that I found for what I found for configuration errors, and these are mostly just contrived examples. But so I would say there's like 3 grouping of cases that I've seen for pods going in the pending. One is configuration errors, and those are usually well represented by the container status of waiting with a valid reason. And yeah, so like this one is, if you have all capitals in your image name, you'll get this kind of state from your container status. Notice the conditions are they're scheduled, they're just not ready, and they're ready false, and container is ready false, which isn't really a valid condition to kind of code against, because there are business as usual cases where all these conditions are set. Image pull back off is one that I don't think we'll be able to target really, because it's a kind of a business as usual case where, I mean, there's stuff like image pull secrets. If you have an invalid image pull secret, it will still go get stuck in an image pull back off. And also if you have an image that doesn't exist, but I think it might be too difficult to try and predict all those cases. So I don't know if we can handle that one with this case. But then so some others are like, if you have an image pull being never, and you're trying to pull, image pull policy is never, and your container doesn't exist, you'll get an error image never pull, but the container still sticks in pending. If you have a missing config map, you'll get a reason that says create container config error. So these are all pretty well represented. The interesting one is actually if you're mounting a secret from, if you're mounting a volume from a secret, or other way around, I may have it mixed up. I noticed that this status actually just says reason is container creating, and the only information you get that knows that it actually failed is in an event. So that is kind of tricky to, I mean, I don't think we're supposed to be relying on events to understand whether or not a pod failed, but in this case, you kind of have to. And the other one that, there's also the case I didn't really cover here, which is if your pod can't get scheduled. I think that is covered by this condition, your pod scheduled is false. And this is an interesting case where if you have a missing volume for your container, your pod will be stuck in pending, but it won't be able to get scheduled. And so kind of what my idea is that I think a lot of these cases can be represented by a potential condition to add to the pod API that sort of kind of reflects invalid image name, some of these images, and then my hope would be that eventually we could use in the retriable job cap. I know they have an image, or they have a retriable policy based off conditions. I would hope that maybe if we have a pod condition that has like configuration errors, we could force jobs to fail. But this was at least kind of my proposal, and I was wondering what this group feels about going forward with this. Obviously, I'm not want to get into design now, but I know there's a KEP in other stages, but I want to know if the idea is good. And I'll open the floor for questions.
I can give some general ideas. I think you got it right that to fit within the API that we already worked on, we have to add a condition. And I think in general, the less different conditions we need to add, the better. And I think you're just proposing one, and that's good. But I think the other thing we need to think about is when or how would pods transition to failed because they are currently impending, right? And that I'm not sure. I'm not sure about, like where should that responsibility fall? Like, I guess one option is it falls within the job. Another option is it fits within the kubelet to fail eventually the pod. So that one I'm not sure where is the best location, or what's the best component to solve. As for the condition, I think kubelet is probably the one that has the best knowledge to do that.
So yeah, so you're saying yeah, I think it would be very clear that the condition will have to be added as part of in the kubelet code. I've done some exploring where that would be, and I know that it's pretty, I think I found the code where that is added in the kubelet to do that. Yeah, so at least the condition, the transitioning to failed, I don't know how to start that conversation.
I think this is a kubelet, like I would expect that the kubelet would be doing that, because you're talking about failing to start the pod, right? And so you think of the pod as like, state machine. Like when it gets created, it's the API server that starts looking at it. After it was created and persisted, it's the scheduler that picks it up, moves it to a stage from unschedulable to schedulable. And once it's assigned to a node, I think of it as like, now it's the responsibility of the kubelet to, progress its status to running. And so I guess that's the point where you're trying to fit, like, make sure that it's included, right? Like in our retriable, that if it gets stuck in starting, you want to transition it to fail, right? Not
Yeah,
like
that would be the goal, and I'm okay with as a alpha or a first round just adding a condition.
Sure. I mean, I'm just like trying to describe like how to think about this, and what the responsibility of, which component is responsible for transitioning that pod to the state from pending to failed, right?
Yeah.
So I would expect that kubelet should be doing that. And so I would present this topic to Signode. Let us know, like maybe, like I'm interested, like if you want to bring this topic to Signode, like one of the Signode meetings, yeah, please ping me, like, or maybe post it on the working group Slack channel that this topic will be discussed there.
Okay.
See what they have to say about it.
I have one question here. So kind of on Abdullah's comment about who's responsible for identifying and maybe changing the state. I was thinking about, like, it depends on why the pod has gone into a pending state, comes into play here as well. So if resources, there aren't enough resources, say on the cluster, and the pod is pending, it is kind of because it hasn't found a node suitable to be placed. I understand that volume provisioning and cases kind of are after the pod has been scheduled on a node and node has taken ownership of that pod. But before that has happened, a pod could stay pending because there aren't enough resources. And in that case, kubelet probably wouldn't be the right place to transition that state from pending to failure. So I was just thinking about that particular case.
Yeah. For that case, we already have the condition, right? Like the unscheduled condition. The schedule already does that. Now, I guess the question is who should delete it? Is that the idea? Like you want it to be deleted, or is it fine to continue to exist there?
Yeah, I think what is being said, or I've looked at it very high level, but the proposal says that we should transition for the pod from pending to failure. So it becomes evident that there's some error and we need to either take some action, maybe provision more resources, make sure that the volumes are available, and that changes from case to case.
Yeah, I think there's a lot of cases is what I was when I was going through the examples. Like I know I didn't really have much examples of this unschedulable one, but I know that that condition is at least well represented. But there's also the configuration cases that I've seen happen a lot, and that is one that I like. It is scheduled. It's just that it gets stuck in pending, and the only way to take it out is you have to have an out of tree controller delete the pod. So at least that is for this. I understand there's a lot of there's a lot more cases than I've covered here.
I think that's a good point. That adding the condition is something that needs to be added by kubelet. The scaler already does, so that's not a problem. But deleting the pod or failing the pod could be done by an external component. And maybe that's a good place to start. Just as prototypes to have an external component do the deletion, and then have it as a proof of concept because and pair it with the job failure policy API to see how useful it is. I think that the major question is how we define how we transition, or when do we transition to fail. We need a timeout at the very least, but maybe timeout is not enough. And if we think of, for example, Unicorn that just presented, the pod can be pending, and I don't know if it would introduce an unschedulable condition, but if it does, it could be because there is no quota, and it doesn't mean that the pod failed, but it will fail later. So I don't know. I don't know about that scenario, for example.
Yeah. I guess I'll think about it a little bit more, and then I'll try to reach out to Signode and see about maybe although you and I can I guess I do like the idea of the job controller picking this out through the pod failure policy just as a proof of concept, because I think the problem we'll run into with kubelet is that it's like we need another state in order to say, like, if there's a configuration and it failed, because like there's I think for containers there's waiting, running, and failed, and like sort of that it might be a pretty large transition to add another like state transition here. At least that's where I was coming at. And then even from the issue I think I posted at the start of this conversation, there was a lot of, I think there was more of a request to have this as an out of tree controller rather than in kubelet. So that was why I kind of went with at least the condition as a starting point, and then starting a conversation about how we want this further down the road. But I think we were over by a few minutes. So I want to.
Yeah, just one last comment on this. If you want to bring it to Signode, and you plan to get this in for 127. Signode is going to have their planning session for 127 next week, so I think it would probably be the right time, and kind of you bring it to Signode and that gets incorporated or at least discussed in the next meeting, because if we don't do that, then it'll move on to the following cycle. So that's
That's
the
good to know.
Yeah.
All right, I will. Is the way to do I just add myself to an agenda on Signode?
Yeah, very much. You just add your name, put in an agenda item, and we can discuss it there.
Okay.
Perfect. Thank you.
All right. Thank you.
Thanks, everyone. Sorry it went over time. I'll see you guys in 2 weeks. Bye bye.